Hello there, you nines. Mr. Herman here, and this is exercise 5E, factorizing by completing the square. Learning goals for this lesson is to know the expanded form of a perfect square, to know how to factorize by first completing the square, and to understand that not all quadratic expressions can be factorized, and to be able to identify those that can't. The success criteria for this lesson is to be able to carry out the process of completing the square. So just like all the other previous exercises, completing this square is a tool in itself in order to factorize a certain expression when we get into a certain scenario. So consider the quadratic expression x squared plus 6x plus 1. We can't factorize this that we're so used to by using the methods that we've already established in the previous exercises because there are no factors of 1 that can actually add up to 6. So in other words, we can't find two numbers that when multiplied together will give me 1 and then also added to give me 6. So we can't necessarily harmonically write it in the expression of x plus and then some number and then some number. This doesn't work for this. Now there is a way around it. We can use our knowledge of perfect squares and the difference of perfect squares to help find factors using surds. Now I know I know some of you cringe at the word of surds because it can get quite confusing. It's not entirely too tricky. There's a few steps that are involved, and we'll run through a couple of examples so you can get the gist of it. So what we need to look into before we consider how to tackle a question like this is we've got to remember that our perfect square rules, when we have a certain number x plus a, that's also in bracketed squared, this expanded version is x squared plus 2 times whatever that a is plus a squared. This here, going from this process to this this expression to this factorized form is what we're going to utilize, and then we're kind of going to deal with the messy surd part towards the end using the difference of perfect squares. Also recall that x minus a, remember a can take on any value. This is the expanded version. We're going to hone in the process of turning this into that there. In order for that to happen, however, we got to do a little bit of backwards working. So how do we complete the square? Here's the expression x squared plus 6x plus 1. And what I'm going to do is I namely want to look at this x squared plus 6x. And what I want to do is I want to add something to this that when I have the ability to factorize it, it will harmonically factorize into an x plus a all squared, whatever this a is. So I'm going to add something onto the end of this. Now the textbook shows you this process and it has fractions involved. So what I'm going to do is look at this x squared plus 6x plus whatever. This takes on the format x squared plus bx plus c, this being this bx. We're going to look at the coefficient in front of the x. Okay, this is a 6, and what we're going to do is we are going to half it and then square it. We are going to half it and then square it. So let's take 6. We are going to half 6, which takes me to 3, and then we're going to square 3, which takes me to 9. So why are we doing this? I'm doing this because if I write this as plus 9, this right here can factorize to a format of x squared plus, not x squared plus 3, big goose, let's try that again, x plus 3 all squared. Because when I expand this out again, this will return me back to x squared plus 6x plus 9. So what I want to do is at the end of this first part, namely here, what I'm going to do is I was correct the first time. Get it together. What I'm going to do is I'm going to add 9. So this right here can then factorize to a nice factorized format of x plus a, or in this case x plus 3 squared. The only problem is I can't just simply add a 9 to this expression. It doesn't balance itself. So whatever I add in this case, I'm also going to subtract. Which in a way kind of seems counterintuitive, because you're like, well, why are you going to add something and then subtract something in the first place? We're just going to end up in the first expression that we started off with. I'm purposely doing this, and I'm allowed to get away with this because this balances itself out, and I'm manipulating this expression here so then I can put it into a format where I can factorize. So if I add something, I can subtract something and then push them to their two separate sides, so I have to deal with one side and then another side. So in this case here, the two sides I'm namely talking about is this x squared plus 6x plus 9. This now can be factorized to x plus 3 squared. And then I'm left with this minus 9 plus 1. Okay, so what I've done here is I've grouped this part over here so I can force it to be factorized. And then now I've got to just kind of deal with this minus 9 plus 1, which is minus 8, by the way. Okay, so we've sort of got there. We've kind of factorized it, but there's still this minus 8 that we have to deal with. Well, what we can do is now we can, and I underlined this at the start, we can use our difference of perfect squares to then factorize this, but we do know that we're going to end up with surds. So in the previous exercise, whenever we end up with two terms where there's a difference and you can force them to be perfect squares, one of them's already, the other one kind of not, you have to change into a surd. This then factorizes to x plus 3 plus a certain term, and x plus 3, I'll move that to the side, minus a certain term. And that term is dictated by what this is. Now this unfortunately is not a perfect square, so you got to force it to be a surd. So in this case here, we have x plus 3 plus root 8 and x plus 3 minus root 8. So we've finally got to a format where it's factorized. It's not perfect and it looks relatively complicated. I remember the first time I saw this, I was like, what is going on? But the reason why we want to factorize this is when we look into, say for instance, sketching a quadratic formula, which you will definitely see in specialist maths or math methods later down the track, you have to know this ability of factorizing fluently and flawlessly in order to get what's called x-interceptions. Now this right here, this isn't fully factorized because I know that I can simplify this surd down to square root of 8 is square root of 4 times the square root of 2. This square root of 8 has a factor of a perfect square, which is 4. So that turns into square root of 2 square root of 2. Square root of 2. Square root of 2. X plus 3 plus 2 root 2. X plus 3 minus 2 root 2. Alright, so here is our finalized, factorized version by using what's called completing the square. I've completed the square by this part here, and then just had to deal with this minus 8 and force it into a format where I can write it in a factorized version. So this process can be deemed quite confusing. As long as you remember, you hone in on whatever that b is, you half it and then square it. That will deal with this, changing that into x plus whatever all squared. Sometimes it could be x minus whatever all squared as well. So let's have a look at a few examples, so you can get a better intuitive feel of this. Here we go. Alright, before we look into that complex example, let's look into an example where we just want to focus on completing the square. So we're going to decide what number must be added to these expressions to complete the square. And then we're going to factorize the resulting perfect square. So there's no surds involved with these type of examples. This is just to get a better feel of how completing the square works. And so remember, when you complete the square, provided that there is no coefficient in front of the x squared, or a is equal to 1 in this case, we're going to look for a number that we can add onto this and then complete the square. So we are changing this. We're not trying to solve for anything. We are purposely changing this here. So this b value is 10. So half of 10 is 5. Alright, so I'm going to write this down. So this b value is equal to 10. So 10, half of 10 is 5. And then 5 squared is 25. So remember, you're halving it, and then you're squaring it. And so we get this 25, and you always just add whatever this number is to the end, regardless of whether it's a minus as well in front of the coefficient of x. So this x squared plus 10x can have a 25 added to this. So then this can factorize down to x plus 5, x plus 5, or x plus 5 all squared. Because when you expand this out, you return back to this x squared plus 10x plus 25. So the skill we're looking at, just for this first question anyway, is knowing what we have to add onto the end of this to complete the square. And how you know what you write in the bracket is whatever the halved value is. So it's 5, x plus 5, x plus 5, or x plus 5 all squared. Second one, we have x squared minus 7x. This minus 7, this b is equal to minus 7. Now this one's going to be a bit of an interesting one, because we now got this odd number. So when you start with -7, when you half -7, instead of writing it as 3.5, because we generally don't see decimals when it comes to factorizing, we leave this as -7 on 2. Okay, so this is the halving process. And then we square this. So when we square this, we're squaring both terms. We're squaring the -7 and the 2 on the top. So this ends up being 49 over 4. And the negative disappears because a negative squared turns into a positive. Negative times negative gives me a positive. So right now, this is the format that we leave it as, 49 over 4. If it can conveniently be simplified down, the fraction can, then you can. In this case, we can't, because of the fact that this coefficient of the x is a odd number. But we can still write this in the format of x squared minus 7x. Remember, this is just still a plus, so you just add 49 over 4. And so how this is written in the factorized format is x, and then whatever this number is. Kind of like what we did with this here. This is a 5. The half is the 5. In this case, the half is just, well, minus 7 over 2. So while it is a bit of an inconvenience having this as an odd number because now we've got this fraction, it is still in its factorized format. What we had to add onto the end of it is the half of what b is squared, which is 49/4. Alright, let's go to look at these two examples here. There is another example within the textbook that involves fractions with some of the questions. That's if the fraction is within the question itself. If you need a bit of help with those fraction type questions, just give me the heads up. For now, I'm just going to focus on these two questions so you can get a better feel of how to factorize by completing the square. So the first thing is I always write down what my b value is. Can we take any, before we even do that, can we take any number out as a common factor? Not necessarily. There's no number in front of the x squared, so you just leave it as is. If you can, if you want to, you can try. You can see if you can find two numbers that when multiplied will give you -3, and then when added will give you +8. There aren't any nice numbers that can work, nice whole numbers that can work, so we need to complete the square. Look at b value, so the coefficient in front of the x is 8. From 8, when we halve this, we get to 4, and then from 4, when we square this, we get to 16. So what we have here is x squared plus 8x plus 16, but then to compensate for this, we also have to minus the 16, and then have this -3 tag along. So now we can complete this square here. Remember, it's always whatever the halved version is. In this case, it's 4. So this turns into x plus 4 all squared, and we know it's a plus because here it's still a plus. And then that's the first part here. Then we have this -16 minus 3, which is -19. It's tagging along. And now we have this difference of perfect, or I wouldn't say perfect squares, difference of squares, not perfect squares because that's not perfect. In this case, this will be x plus 4 plus the square root of 19, and x plus 4 minus the square root of 19. The square root of 19 cannot be simplified down any further, seeing as though 19 is a prime number, so this is the final format of the question. Alright, last example, we have x squared minus 2x plus 8. Our b value is -2, so -2 halved will give me -1, and then -1 squared will just give me a 1. So what we have here is x squared minus 2x plus 1 minus 1 plus 8. Now before I continue on with this question, let's backtrack. Factorize the following by completing the square if possible. We're actually going to run into a situation where this is not possible to factorize. And we'll see why. So for now, this right here can factorize into x, whatever this number is. So -1 all squared, so that's the first part. And -1 plus 8 will give me plus 7. We cannot factorize this. This cannot be factorized because in order to do the difference of squares, there has to be a difference. There has to be a takeaway sign. This right here is not a takeaway sign. This is a plus sign. And because of this, this cannot be factorized. This cannot be factorized. If you ever get to a question that looks like this, and you write, this can't be factorized, you've got to show why. You've got to get to this step right here, indicate that there is a plus there. You don't necessarily, you just got to write that there's a plus there. As soon as I see, yep, there's a plus, this can't be factorized, and the prior steps to that are all done correctly, you can just write that this cannot be factorized, and you will get your fully allocated marks for this. If there was a mistake and this was meant to be a negative, and you put a positive or plus there for whatever arithmetic mistake reason why, and then you say this cannot be factorized, you won't get your allocated marks if you make the mistake. But if you show all full working out and you get to a step, and I know for a fact it can't be factorized, and you show that, that's where you get your fully allocated marks. So you will get scenarios where you cannot fully factorize by completing the square because there's no difference. Okay, that is it for this exercise. Have a go at the questions. Please make sure that you don't use a log sheet for your questions, but you rather use a weekly planner. I do a few adjustments to the actual questions itself. But I also elaborate on what type of questions are extension questions if you're feeling a bit overwhelmed with the amount of questions that you have to do. Okay, so on the weekly planner, which looks like this, is a bit cropped. So questions 2, 3, and 4, every second one, and for extension you can do 680G and 780G. Use this as your reference rather than a log sheet. It just makes it that much easier. Alright guys, that's the end of exercise 5E, factorizing by completing the square. I'll catch you guys in the next video for 5F. See you then.